So the first couple problems here are a review from what we did before.
Yeah.
So the first thing I want you to check on all of these problems, however, is right here. Is there something they have in common that you can take out? So if I look at number 1, do they have something in common? What do they have in common?
B.
If I take out a B, what would be left inside?
B plus 1.
Okay. Now, something I'm going to point out. This has how many B's? 2. Not counting that one, just looking at the one with the highest exponent. That's called the degree. How many B's are in the answer? 2. So every time that there's a squared, I should see 2 of those in my answer. This we learned was called what? Undistributing. It's not officially called that. That's just my word for it. What can I take out here?
R.
What would be left inside?
R plus 8.
And that leaves me with that. Yes?
Yeah.
Okay. That's easy, right? So my next question, number 3, do they have something in common that I can take out? No. So this one is not an undistributing problem. It's an unmultiplying problem. In other words, there were originally 2 sets of parentheses and a 2 by 2 box, and when it was multiplied, this was the answer. Does that make sense? So we need to come up with the 2 parentheses that were multiplied and got this as an answer. So I have a trick for it. I call it the snowflake. Some other teachers call it the super X, but it's basically an X with a little belt across it. And I'm going to show you how this snowflake works. You ready? Good answer. So on the top, I'm going to put A times C. What in the world do I mean by A plus C? Do you remember what standard form is?
Yes.
Remember that? So when I'm talking about A times C, I'm talking about the number that's in front of the X squared and then the number that doesn't have an X. Now everything we're doing today, as you can see from the title, A is going to be 1. Tomorrow we'll get into the A not being 1. So A is 1 because it's not there, it's a 1. Times 6 is 6. On the bottom, I'm going to put the B value. What is the B value? 5. So I have 6 on top and I have 5 on the bottom. Now here's the one part where you have to think for a bit. What 2 numbers multiply to get 6, multiply to get the number on top, and add to get the number on the bottom? They have to do both. 2 and 3. So 2 times 3 is 6, and 2 plus 3 is 5. Yes?
Yeah.
Okay, so that's the hard part. Now I take my x squared, that's 2 x's, right? I'm going to split it up. 1 goes here, 1 goes here. And I'm going to look here. If this was a fraction, could it reduce? X over 2. No. If this was a fraction, could it reduce? No. If they could reduce, I have to reduce them. But these are what are going to go in the parentheses. So I have an x and a positive 2. X, positive 2. And x and positive 3. X, positive 3. Those are my 2 parentheses. Can I check my work if I want to?
Yeah.
How would I check my work? Put in the box. X and 2, x and 3. That gives me x squared, 3x, 2x, and 6. So x squared plus 5x plus 6. Got it. Okay. Now there's not really anything magical about this snowflake. It's just a way of kind of organizing it, and it helps us put things together. But if you notice my 2 numbers here, they're the numbers that end up right here, becoming the like terms that I can combine. So it is very related to that. Okay? All right, let's try this guy. Again, do they have anything in common? That's the first thing you need to check. Do they have anything in common? No. So I'm going to go to my fancy snowflake, or super X. And on the top, again, I'm going to put A times C. What is A? 1. And C is negative 10. So I have to put negative 10 because 1 times negative 10 is negative 10. On the bottom, I'm going to put my B value. What is my B value? Positive 3. And I need two numbers that multiply to get negative 10, but add to get positive 3. Let's see. Thinking about multiplying to get 10, there's only a couple options. It's either 5 and 2 in some combination or 1 and 10. So I think it's going to be 5 and 2 because 1 and 10 is not going to get me a 3 very easily. But this is a negative 10, so one of these two things has to be negative. Does it matter which one I make negative?
Yes.
What if I make this one negative?
It's not going to equal 3.
Negative 5 times 2 equals negative 10, but negative 5 plus 2 is negative 3, not positive 3. So it does matter where I put the negative sign. 5 times negative 2, there's your negative 10. 5 plus negative 2, there's your 3. So it does matter where you put the negative sign. It doesn't matter if you write 5 and negative 2 or if you write negative 2 and 5. That doesn't matter which one's on which side. Okay? So I'm going to take my m squared. I'm going to split it into m and m. M and m. Now I want chocolate. Okay. Can that reduce? M over 5. Nope. What about m over negative 2? So I have m plus 5 and m minus 2. Now I ask about the reducing. Today nothing's going to reduce, but starting tomorrow when we have a values that are not 1, it will reduce. So I want you to get in the habit of asking yourself, can it reduce? Okay? Kind of sort of get it? You want to try 5 and 6 on your own? All right, I'm going to give you a minute. Try 5 and 6 on your own. Okay. So, is there anything I can take out? No. Okay. What goes on the top? A times C, which is 1 times 6. And on the bottom, negative 5. What are two numbers that multiply to get 6 and add to get negative 5? Negative 2 and negative 3. What if 2 and 3 didn't work? Well, what are the other two numbers that multiply to get 6? 1 and 6. Right? They would have to work. All right, I split up my n. Can this reduce? Can this reduce? I have n minus 2, n minus 3. Easy peasy, right? We're going to practice this over and over and over and over. You're going to love it. Okay, what goes on the top here? Negative 21. And what goes on the bottom? All right, two numbers that multiply to get negative 21 and add to get negative 4. Negative 7 and positive 3. Can I call it positive 7 and negative 3? No, because that would get a positive 4 here, not a negative 4. Okay? All right, I take my n squared and I split it up. N minus 7 and n plus 3. Yeah? Is that what you got? Okay. By the way, remember how I said up at the top, whenever you have like a squared, you should have 2 of them in your answer? Does that follow for these? Like I had m squared was the biggest m and m. N squared, I have n and n. This time I have how many? 3. So how many should be in my answer? 3, right? Now, my snowflake only gives me 2, so what's the problem with this one? You want a hint? Do they have something in common? What can come out? So when I take an r out, what's left inside? R squared minus 15r plus 50. So that means when I write my final answer is going to have an r out in front and then my 2 parentheses. Does that make sense? Yeah. That's where the third one is. So what's going to go on top here? 1 times 50 is 50. Negative 15 on the bottom. What are two numbers that multiply to get 50 and add to get negative 15? 10 and 5? Those add to get 50. Right now they add to get positive 15. They both have to be negative. Both negatives will still multiply to get 50. And now they'll add to get negative 15. So now I split up my R's. Today I can't reduce those, but I do need to check. R minus 10, R minus 5, 1, 2, 3 R's. I'm good. Okay? All right, you try number 8. Exact same type of problem. What can come out? An x can come out. So I have x squared plus 3x minus 10. So my answer is going to have an x out in front of my two parentheses. What goes on the top of my snowflake? And the bottom? What are my two numbers? Negative 2 and 5. What would happen if you put 5 and negative 2 instead? That would just mean that whatever I get for my second parentheses, you would have written in your first parentheses. So it doesn't matter that order there. Okay? Put my x and my x, so I have x minus 2 and x plus 5. Easy peasy. Okay, let's look at number 9. What do those three have in common?
2R.
Not 2R. R to the second. So what would that leave inside? R to the second plus what? 3R plus 2. So this time I'm going to have R squared out in front of my parentheses, right? So let's see. Because there has to be 4 in my answer, right? So 1 will be in that parentheses, 1 will be in that parentheses, and then there's the other 2. What goes on the top? 2, and on the bottom, 3. What are two numbers that multiply to get 2 and add to get 3?
1 and 2.
1 and 2. Here's my R and my R, so I have R plus 1 and R plus 2. All right, you try number 10. Bless you. There's my answer all set up. What goes on the top? And on the bottom? What are my two numbers? 9 and 7. So I have x plus 9 and x plus 7. Now, something I want to make sure is clear to you. Each of these that I did, these 4 where there was something in common, all just had a letter in common. But we should know from our previous homework that you might have more than just a letter in common. You might have a number in common also, right? I had some students last period asking me about this one. They get to this problem and they're like, whoa, those are really big numbers. I don't know what to do. Well, my first suggestion, take out a 6. What's 90 divided by 6? Let's see. Oops. 90 divided by 6 is 15. And 324 is 54. So I'm going to have a 6, and then I'm going to have my 2 sets of parentheses. And those numbers are a whole lot more doable than 6, 90, and 324, right? So when you get those big numbers, your hint should be take something out first to make it more manageable. Okay? All right. Happy studying.